Common polygons. Polygons is a word for something that has many sides or angles. So what we're looking at is we're going to be looking at least a minimum of three-sided shapes, except for a circle. Though it would be interesting because it doesn't have sides or angles. We just call it circle. So let's go through a couple and the most common and what their definitions are. Okay. The first one that most people know is square, but it does have a definite rule. And square means that the length of the side is the same all the way around this square, or this polygon, which means it is square. So you'll hear things like, for instance, in our past lessons, when we had like a base, like 3, and we had it raised to an exponent of 2, if we said that, you would say that's 3 to the power of 2, or 3 to the second power, or another way they called it was square. Now, the reason it's called square is definitely because of geometry. Because in geometry, having 3 squared actually means that your length and your width are the same number. And if I multiply those, that is a complete square, okay, where all sides are the same. That's why something that is raised to the power of 2 has a geometry connotation, which means you're talking about a square where the length and the width are exactly the same. That's why that name came from. So let's talk about the next one. The next most common is rectangle. Rectangle definitely has a vocabulary word that goes with it. What it says is that the opposing sides, which means this side and this side, have exactly the same length, and that or width in this idea, and that the other opposing sides have the exact same length. So if we give an example of that, that means that if I call this width 3, then its opposing side is also 3. If I call this length 5, then it means its opposing length is also 5. The next shape that we're going to work with is something called a triangle. Now, for definition, there's actually 3, 4 types of triangles. Let's talk about them, okay? It does mean 3 sides, okay? But let's say all the sides are equal. Let's say this one, all sides are equal. Let's say this is equal to 7. This is also equal to 7. This is also equal to 7. Well, a triangle that has all the sides equal is called equilateral. Okay. That's where all sides are the same. The next one is where only the 2 sides are the same. We call them legs. If this leg is the same as this leg, and they're the same, but they're not the same as the base, that's called isosceles. So let's make sure I'm spelling this right. Hate to get us started. Isosceles. Oh, there it goes. Let's say isosceles. There we go. Isosceles triangle. Oh my God, my spelling. Help me. Okay, let's talk about another one. So this one, the first one was all 3 sides are the same. The next one was all 2 sides are the same. The next one is where no sides are the same. So this actually will look like something crazy, something like this. This one shows that no sides have the same length. They are all different. And if they're all different, this is called scaling. And there is one more triangle, and it's called the right triangle. It's a very common and very useful triangle. It's where one angle is worth 90 degrees. And this is called right. So 4 different triangles. Do they have different like formulas when it comes to area? And the answer is no. No, you're going to use the same formula on area for all of these triangles. So when it comes to that, you have one formula and it works with all four. Okay. The next one is a circle. Now, a circle isn't really doesn't have any sides or angles. Well, it's special. So it is gonna have its own vocabulary that goes with it. One of the vocabulary words that you're gonna be talking about with circle is the word diameter. Sorry. Oh my God. Diameter. Now, that vocabulary word means it's directly from one side of the circle all the way across through the middle to the other side. They usually call that the mouth of a circle or a jar. You would say it's the mouth of the jar, the opening. So it is the widest part of a circle. So this means all the way across. So that's what you would measure if you're like finding a lid for a jar. You would go and measure the widest part, which is the diameter, and then you go find a lid for that. There is another vocabulary word that goes with this, and that vocabulary word is radius. Now, the radius, what it is it's from the middle of the circle to one of the sides, or just to one side like that. That measurement is called radius. It's technically halfway. So if you know the diameter, let's say the diameter for this circle here was 10. That's the diameter. We usually say d equals. Well, then the radius, by definition, is half of the diameter. So the radius would be 5. Okay. One more vocabulary word that you're going to get with this is circumference. And circumference is, by definition, it's the distance from one side of the circle all the way around. Again, that would be called the circumference, and it's the distance around. So the one thing about the geometry is it does have a lot of vocabulary, and that's why it's a full year in school because there is so much vocabulary that goes with everything. And because of the vocabulary, there's rules and there's guides that must be followed. So, here's this right triangle. One of the corners is worth, or one of the angles inside is worth 90 degrees. Okay. Let's look at a few more. There is a few more. One is called a parallelogram. Okay. The best way to describe a parallelogram is the same thing that you would say it's a crooked rectangle. So if I say it's a crooked rectangle, that means its rules are going to apply the same, which means a rectangle says that this side is the same as its opposing side, and this bottom is the same as its opposing top. Now, the one thing about this parallelogram is you're going to have to talk about h, which is equal to height. Now, height is going to be from the lowest part, which is here, to the highest part, which would be there. According to the parallelogram, this is the height of it. So you have to be careful with the parallelogram. Part of the formula for area has an h, and that h does stand for height. Let's look at the rhombus. The rhombus, let's call it a crooked square. So because it has the word square in it, that vocabulary will carry over, which means all the sides are the same. Again, because it is crooked, and we're looking at, if we are talking about area of a rhombus, one of the definitions is going to be h also. And again, that's equal to height. And height is also going to be from the lowest point to the highest point. That would be considered H. Trapezoid. Trapezoid looks like a triangle with the top cut off. So what we look at is we would say, well, this side here is the same as this side here, which means their lengths are the same. Now, what's interesting about a trapezoid is they're going to use the word base. Now, you might think that you might think correctly that you would say, well, the bottom, I would call that a base, and I would agree with you. But they also do something interesting. They call the top a base too. So you have two bases. So when we start talking about the trapezoid with like area, and we start talking about, you see a B for base, you're going to see things like B1 and B2. B1 refers to base 1. We usually would say B1 is the bottom. Does it matter? Not really. But you would say B1 is the bottom. And B2, we usually call the top B2. So you're going to have some definitions thrown at you. You're going to have some symboling thrown at you. And that's what takes a little bit of time, is learning the symbols of the geometry formulas and what they actually represent.